Okay, it's been a while since I've done some of these, but now I'm going to skip ahead by special request, and I'm going to try and answer this question here. So this is just a pretty basic one when it comes to increasing annuities, increasing continuous annuities actually. So to start with, the force of interest, which is what we need for a continuous calculation, delta, is 6%. It doesn't matter whether that's per annum or whatever. So find the value of this increasing annuity that's got a term of 10 years or 10 payment periods. So what is the formula for something like this? So the formula, actually I'll just say if it were n, then over there, then the formula is actually, it is a continuous annuity with that same period, n, minus, it is the number of periods, n, times the discount rate to the power of n, divided by delta, the force of interest. It actually doesn't look very good. I'm going to do it one more time. So that's what it is. So in this case, what we're going to be doing is, we're going to be calculating this, but instead of the n's, we're going to make it a 10. So that'll be a 10, that'll be a 10. It says no, but it's actually a 10. And this will also be a 10. Sorry, that looks really bad. Anyway, so now to work it out. So for a continuous annuity, basically it's got a very similar calculation, almost exactly the same as a regular annuity, but the difference is, so this is a regular annuity over here, and inside this discount part over here, that's actually 1 on 1 plus I. So we're using this interest rate I, but we're not using that in the question, it's using delta. So to find that I, we've got to do something. And so if that bit over there, I'll just get rid of that. So I'll just draw a line here. If this is the calculation for an annuity, how do we turn that into a continuous annuity? So what we do is a continuous annuity of that term is actually equal to I over delta times that regular annuity. And we know that in this formula we have a denominator of I. So that's actually going to be I on delta times 1 minus v to the n on I. Those two cancel out, and it's actually over delta. So it becomes 1 on v to the n over delta, but still we know that inside of here it is that 1 on 1 plus I, that discount factor. So we can't forget that when we're doing this. Now that we've got that, everything's quite easy, and basically the formula is going to be looking like this. The 10 will be equal to 1 minus v with that I over there to the 10 divided by delta, which is 0.06, minus 10 v to the 10, and inside here again we have 1 on 1 plus I. So we can't start mistaking that for delta, and the whole thing is divided by delta, which is 0.06. I actually should have put that one in there. Sorry, I'm just going to make that smaller. So that is actually 0.06, and here 0.06. And I'm going to use Excel to calculate this. One last thing that we don't have is we don't have I. And I'll just write over here that we happen to know that 1 plus I is actually equal to e the delta. So in that case, 1 plus I will be e to the 0.06. So I is e to the 0.06 minus, sorry, not minus 1 up there. The entire thing is minus 1. Minus 1. And that's going to be whatever it is, somewhere around 0.06. So once we've got that, we can really just use Excel and come to some fantastic answer. So I'm going to do that. Hopefully everything all works out. So let's find I. We'll put it over here. So I is going to be equal to exponential 0.06 minus 1 equals that. That's our I. Then we can also use V is equal to 1 divided by 1 plus I over there, and that is our discount factor. And so we can also calculate, I can have that delta is 0.06, and I can say n is 10, and that's pretty much all the variables that we've got. So let's find out what an annuity certain is. So this can be our continuous annuity, A, and that's going to be equal to 1 minus, will be v to the power of n, which is 10, and that's divided by delta, we decided. Okay, and you can skip back to see the formula again. That is the value of our annuity. Then we're doing A minus, it is n times v to the n. So it's actually n times v to the power of n, even though, you know, that looks a bit weird. So that will equal this number here, 10 times v, this discount factor, to the power of 10, or n. And that's that number there, and it's that whole thing divided by delta. So it'll be equal to A, sorry, I'll do that again, put in brackets, A minus n times v to the n divided by delta, and that's the value of our annuity, 33.86. 33.86 dollars, pounds, cents, whatever, and that's how it's done. That's the answer of this increasing annuity over 10 periods.